Hi folks, welcome to CamLogic's Tech Tuesdays. Today's presentation will start in just a minute. Hello everyone, thank you again and welcome to this week's edition of CamLogic's Tech Tuesday. My name is Chris Himberg and I am one of the application engineers here at CamLogic. Tech Tuesday is our free weekly tips and tricks webinar, and today's topic is 3D printing best practices. But first, let's familiarize everyone with CamLogic. CamLogic has been in the CAD/CAM CAE space for over 35 years. The company was established over 16 years ago, initially focused on CAM, servicing mainly the tool and die shops in the area. As the market evolved, CamLogic also evolved, interestingly working our way backwards from manufacturing to the concept of the idea or design. And so because of this, since we started toward the end of the production process and worked our way toward the beginning, CamLogic has the fundamental knowledge of what has to be done to assure that each step of the process will result in a product that will actually work or fit into the next phase of development. CamLogic has chosen to represent software and tools that enable our customers to fulfill the full cycle of product development. We consider ourselves integrators and partners for our customers, not just resellers. So CamLogic employs sort of the three-legged stool technology. We partner with Siemens, offering the complete integrated Siemens portfolio for design, machining, analysis, and data storage and retrieval. We also partner with 3D Systems for 3D printing and rapid prototyping, and Steinbeckler white light and blue light scanners, and Creaform for 3D scanning for inspection, quality, and reverse engineering. So now that you've heard a little bit about who we are here at CamLogic, let's move on to today's topic. So 3D printing best practices. Here's a little overview of what we're going to be covering today. The first, obviously, is the file creation for what we're going to be printing. Most of what we're going to be talking about will revolve around the STL file. And we'll talk about what an STL file is and how we create one, and more importantly, how we create a good STL file. So we're going to be talking about things like watertight STL file. We'll be touching on faceting and normals. And we'll also talk about Vermel files, which are similar to STL files, but they actually support color. So if you have a printer that supports color, we'll touch on Vermel files. Obviously, we'll talk about part orientation in your printer. That is actually a very important aspect that I think sometimes gets overlooked. So when we have features such as cylinders or holes, we need to, again, think about part orientation regarding those features and how we're going to orient the part to minimize our print time, because obviously we're excited to see what's going to come out of this thing and we want it to happen as quickly as possible. Also, the printing environment. So temperature and humidity affect the printer, most printers, and they're going to affect the print quality from those printers. Environment stability, and here in Michigan, we have all 4 seasons, and of course the temperature and humidity is going to change with the seasons, and so that needs to be considered as well. So print file creation. Good printed part starts with a good STL or Vermel. It's sort of like if you're doing a paint job, right? It's all about the preparation. So this is where we're going to start, and for us being associated with 3D Systems, we're going to be talking about ZPrint and ZEdit Pro. So we're going to jump in here into ZEdit Pro, and what we have here is a little CamLogic logo that I designed up in NX. And so the first thing I want to talk about is, what is this? This is an STL file, but what does that really mean? So an STL file is a stereolithography file, and it's basically a triangulated mesh that describes the surface of the part. So what we have is basically a bunch of triangles. When I turn the edges on, you can see all the triangles that make up this surface data. Now, what's important to note here is that this is not a CAD model. This is not parametric. There is no math that's behind the features of this model. This is a static model that, when you scale it up or down, is going to reveal all these triangles as you see them. It's not going to be able to re-smooth any of these surfaces if you scale it up. So what we see here is some faceting on this model, and that's on purpose. I did this to illustrate the fact that when you create an STL file from your CAD package or what have you, resolution is going to be something that you're going to want to think about. So based on the capabilities of whatever printer you may have, you're going to want to make sure that the STL file that you create minimizes this faceting. So if we were to print this on our Z Printer 650, these flat edges that are along the curvature of this C here, those would be seen. Those would be printed, and we could do a little bit better of a job. So if we go up here and open another file that I've created, and again, we're going to say that this is in inches. There are no units associated with an STL file, so it's going to ask you. I know that I created this in inches, so that's what we're going to load the part with. We can see here that we've got a lot more triangles going on around this curve. So what we end up with is a much more high resolution model. And when this prints, this is going to be a nice smooth curve all the way around, and that's what we're really looking for. We really want to maximize the capabilities of the printers that we have. So that's definitely something to keep in mind. What you may also notice is that on these flat surfaces, we have these really big triangles. Now what's nice is that CAD packages especially are very good at recognizing that this flat surface really doesn't need that many triangles to describe the surface, because it doesn't really change. So when we look at this, this crossbar here on the A versus the curvature of the C, obviously to describe this curvature with the accuracy that I told it to, it's going to have to create a lot more triangles. That means a lot more data, which means a larger file. So that's also something that you need to consider. Obviously, when we increase the resolution, we're going to be increasing the file size as well. So the other thing to notice here is that this model is watertight. What does that mean? It means that there are no holes and there's no gaps. Every single edge of these triangles is touching another triangle. That's very important when we go to load this into the printing software, and we will go over that here in a few minutes. So I think maybe to reiterate this resolution and faceting, again, these STL files are not CAD files. I brought up NX here. This is the application that I use to actually design our logo here in 3D. And you can see that this actually is a full parametric CAD model. We've got some text as curves here. I've got some sketches, some extrudes. So this is a full-blown CAD model. And when I say that there's no math behind an STL file, and we all know that there is for a CAD file, what that means is that when I zoom in here and I start to see this faceting, sort of like I did on the STL file, what I can do is I can go up and actually regenerate this view. And what that's going to do is it's going to tell NX to go back and recalculate all the math and rerun all of the formulas that describe this part, and we can see that we end up again with a nice smooth curve. And we can zoom in even further and regenerate that model again, and it will re-smooth all of those curves, rerunning all of those math models in the background. Again, with a STL file, when we zoom in and we start to see the edges of these triangles, we don't have the option to regenerate this view. We can't recalculate this. So we're sort of stuck with what we have here. So again, it's important to go through whatever package you're creating your STL file in and make sure that your resolution is set properly. So I mentioned this model being watertight. Let's open up one that's not, and let's see what happens. So I have a model here that I purposely have put a hole in. So we look at this model and we say, well, looks fine to me. But when we start to inspect it a little bit further, we see that we've got a little bit of a gap here. We've got some faces that are missing. And what happens is we can actually see right into the model here. Now, basically what that means is this water is not watertight. So what we need to do is we need to run some sort of repair to fix that, because if we hop over to ZPrint here, we can load this model. Again, we're going to tell it we're in inches. And when we zoom in, we see that hole. So what does that really mean as far as what this is going to come out like when we print this? Well, in ZPrint, we have this nice option here where we can go into 2D. And so what we're seeing here is sort of a top-down view here on the right of what the printer is going to print for each layer. So this is the very bottom layer. This is the first layer the printer is going to print. And we can see that that line going through the word CAM is white. Now, the black areas represent where the printer will print, and the white areas represent where the printer will not print. So what we're going to end up with is our model is basically going to be cut in half. So because those edges were missing, the software can't tell the printer to print this model properly. So again, this is this is a problem because we want our models to come out looking nice. So what do? Well, in ZEdit Pro, we can just come in and we can run through the automatic repair. And what it's going to do is it's going to identify that gap, and it's going to say that it's going to require fixing. Okay. And so what we're going to do is we're going to change over to the repair color mode. Now what this has done is it's colorized the triangles based on their normal orientation. We mentioned normal a little bit earlier. What that means is each one of these triangles has a front and a back, or an inside and outside, or however you want to think about it. And we need to make sure that we are only looking at the outsides of these triangles. So here we can see the blue, which represents the inside, which is not good. So we have this gap identified, and we can go in here and we can repair that and say OK, and ZEdit Pro fills in that gap with the necessary triangles. So we can zoom out. Now we've got a good watertight model that we can send over to ZPrint and print on the printer. Now, there's one other issue that we need to talk about regarding normals, and that is inverted normals. So let's open up another file here. Inverted. Tell it that we are in inches. All right. So again, similar looking model, but we have this line extruded surface going through here that's gray. Now that's not right. That's not how the other ones looked. So if we switch over again to our repair color mode, we see that we've got these pink triangles, and we know that those are good. We're seeing the outsides of those, but these blue triangles, that's actually surfaces that are flipped inside out. So we're looking at the wrong side of those triangles. And again, this is something that there may be one triangle, right down here that somehow got flipped when you exported your STL that could potentially cause a problem for your print job. So we need to address this, because if we don't, again, if we go back to ZPrint and we can load up that file, let's see, inverted, and we'll see what's going to happen if we don't address this. Again, we can go into our 2D mode to see what the see each individual slice of what the printer is going to think about this. And again, we've got a part that's cut in half. So what do we do? Again, we're going to go back into ZEdit Pro, and we're going to open up our tool window. And we're going to run our automatic repair, because our automatic repair checks for gaps and it checks for inverted normals. So it says, hey, those guys are inside out. So it flips them around, and lo and behold, we've got a model that's ready to go. So again, the models need to be watertight, so no gaps, no holes, and all the normals for the triangles need to be oriented properly for your model to print successfully. One other thing that we can talk about is a Vermel file. We sort of mentioned this a little bit earlier. A Vermel file, as I said, is basically an STL. It is a triangulated mesh, and Vermel was conceived actually for virtual reality. It stands for Virtual Reality Modeling Language, and what we see here is that it actually supports color. Not only that, it supports parameters such as shininess and transparency. So as I mentioned, it's designed for virtual reality and gaming and creating realistic worlds that you would move through virtually. So those things are supported. They're not really applicable in the 3D printing world, but just thought I'd throw that out there. So again, resolution is huge. This is sort of the high definition model. We want to make sure that is something that we consider when creating these Vermel files. It's really just a matter of coloring the surfaces in whatever package you might be creating that model in and exporting as a Vermel file. They have the file extension of WRL, and most print softwares that support color will handle a Vermel file, so that shouldn't be an issue. So talking about part orientation, no, you can't really just load your file and hit the print button. Of course you can, but you may not be terribly happy with the results. So what we're going to do is we're going to go back into ZPrint, and we're going to get rid of these models that we know aren't going to print very well. We want to get one up here that's going to come out looking good. So let's grab our high definition model, and we'll load that in. Now, when we're talking about orientation for printing, the first thing that we want to think about is, again, how long is this print going to take? Well, in most cases, the length of time that the print will take is based on the Z height of the model. All right, so right now we're looking at this thing's only about 1/4 of an inch tall, so this is going to print pretty quickly. If we were to rotate this guy, so we can rotate it 20 degrees and tip it up on its head. Now, we've just probably increased our print time probably 5-fold just by making that quick little change. And we really haven't done anything to make the model come out any better when it's printed. Because when we're talking about 3D printing and building layer by layer, there's a few things we want to think about as far as the features that are in our model. I mentioned cylinders and holes. You really want to try and make sure that your cylinders and holes are along the z-axis. The reason for that is if we were to take this guy and rotate it 90 degrees that way, I know that's upside down, but that's okay. What could potentially happen is that as these layers build and build and build vertically, this model may begin to squish, especially on the C here, because we don't really have anything supporting this. So again, this could happen with any cylinder, any hole that you may have in your model if there's not sufficient material to hold that part in place. So really, the best orientation for this particular model is really just laying flat. It's going to satisfy the requirements for the holes and cylinders as far as being along the z-axis, and it's really going to minimize the height in the z-axis, which is going to minimize our print time. We also have another print software that we can look at. This is the print preview for 3D Systems ProJet line. If we open that same model and bring that in, pretty much we have the same functionality where we can take this model, we can rotate it if we want, we can tip it up. And what we want to think about for this particular printer, and this is something really to think about your own particular printer that you may be running, because they all sort of have their own personality, their own little quirks and things that they do well and things that they don't do well. This printer in particular really likes to have each layer be as small of a cross-section as possible. So of course we could go ahead and tip this guy up another 70 degrees and have it standing straight up, and you say, well, that's obviously the smallest cross-section you're going to get. Well, that's true, but I know that I could probably get away with, backing that guy down, maybe to there, and what that's going to do is I just reduced my print time by probably a few hours just by making that simple change, and I know that having it on an angle like that is going to satisfy the requirement for this particular printer to have those cross sections be relatively small. So again, get to know the printer that you're running, understand its little quirks and eccentricities, if you will, and really try and experiment with that and find out what part orientation is going to work best for you. These are the ones that I've found that work best for the Z printer and the ProJet printers. And so the other thing that I want to talk about, since we're in the print preview here for the ProJet stuff, is all the softwares are obviously different as well. So if we were to bring in our model here with these inverted normals, we can bring that in and bring it into our build chamber here. And again, we can see that we've got this gap that's going through the C, the A, and the M. So what we do in this software is we're going to select the part, come up to Tools and hit Verify. It's going to say that the selected parts have been successfully verified, and we hit OK, and it will go ahead and reverse all those normals for us. So now we can come in here and we know that this is a solid model and that it will print successfully. So just to illustrate that, different softwares usually can accomplish the same tasks. The buttons just may be in a different spot. So again, learning the software that runs your printer and really being on the lookout for those little defects that may come up in your model and that may cause your print to fail, or at least come out in a way that you had not intended. So that was the 3D Systems Z Printer 650 and the ProJet 3510, the two softwares that we saw there. Now, printer environment, my rule of thumb is that if you're not comfortable, there's a good chance that your printer probably isn't either. Now, the reason for that, again, as we mentioned, was mostly temperature and humidity. Almost all 3D printers use some sort of heated material that is then cooled or some other way hardened to support the next layer. So when we talk about temperature and humidity, we're talking about the general vicinity around the printer, but we're also talking about the actual build chamber, what's actually going on inside the printer. And that really should be monitored and really kept under control as much as possible, especially for, again, in my experience, the Z printers, because it's a powder-based printer. High humidity is going to cause that powder to sort of clump up a little bit, and even low humidity, extremely low humidity, you're going to see a buildup of static electricity, which is going to cause almost the same effect. So you want to stay away from that. Again, most humans aren't comfortable at 10% relative humidity, nor at 90%. So stay away from that. Environment stability, again, keeping those variables controlled is always good. Vibrations and things like that are never good for a 3D printer, so you're certainly not going to want to install your 3D printer next to a 50-ton press out in the shop. So you're not really going to be happy with the prints coming from that printer. And again, changing with the seasons. This is certainly something that we struggle with here in the Midwest with our hot and humid summers and our cold, dry winters, keeping things here in the office consistent and keeping the environment in such a way that the printers will actually print nice parts for us. So that pretty much wraps up today's Tech Tuesday. Thank you for tuning in. You can find this Tech Tuesday on YouTube. You can see our YouTube address down there, youtube.com/user/camlogic. And thank you again, and we hope to see you soon. Have a great day.